This is my project on the melting of the polar ice caps and its effects on thermohaline circulation. So, first off, we have information and vocabulary. So, we have the polar ice caps here, which are sheets of ice that cover the poles on Earth. Then we have thermohaline circulation, which is the process of water masses and currents moving around the world's oceans along a sort of conveyor belt, where warm, fast currents along the edges of ocean basins move heat from the equator towards the North and South poles, where it cools and sinks. This water then joins the slow moving ocean currents in the deep ocean, which are driven by density differences. The water from the conveyor belt is very important in delivering nutrients, oxygen, and heat, thus supporting life and regulating weather patterns around the world. The cycle is caused by global wind patterns, the Earth's rotation, and differences in water density. Next, we have the Atlantic Meridional Overturning Circulation, or AMOC, which is a component of thermohaline circulation based in the Atlantic Ocean. And it brings warm water up to the Arctic region through the Gulf Stream, where it then gets colder and sinks and continues the cycle. And then finally, we have water density, which is affected by temperature and salinity. And salty water is denser than fresh water, while cold water is denser than hot water. So here's my hypothesis, and it's that the melting of the polar ice caps caused by climate change will lead to the continued weakening of the ocean conveyor belt by disrupting the density of polar waters with a large influx of less dense fresh water. The degradation of the conveyor belt could soon lead to an abrupt global weather event like an ice age. So for my data set, I used the sea ice index, which is a measure of how much ice remains in the polar regions at any given moment. And it shows changes in Arctic and Antarctic sea ice while also providing trends and anomalies in ice cover. The data is compiled and analyzed by the National Snow and Ice Data Center, also known as NSIDC, based at the University of Boulder in Colorado. They're funded by NASA to archive and distribute data from NASA's past and current satellites. The NSIDC don't collect the ice sheet data themselves, but instead they analyze the data that they receive from NASA satellites. And how do the satellites measure? So basically, they use passive microwaves, they're called, to determine the height of the ice surface above sea level, which can then be used to calculate the overall ice thickness when combined with other assumptions about ice density. Um, the microwave sensor is called passive because instead of sending out a signal, it actually measures the microwave radiation naturally emitted by objects or surfaces that it's detecting. And due to their frequency, microwaves can penetrate clouds and dust, which makes them really useful for collecting data in the polar regions when there's massive storms and there's periods of just total darkness. Also, the satellites they use, they have a bunch of different models listed there, most of which are now retired, but even the retired satellites, the NSIDC can still collect the data from those. Um, so where do they collect this data on sea ice extent? It's in the yellow shaded regions on this map. So basically, it's just away from the equator and the tropics and the subtropics. And when has this data been collected? Since November 1978, and it continues to this day. Um, the data set measures the variables of sea ice extent, sea ice total area, and sea ice growth rates. And I worked with sea ice extent and the growth rate data. So basically, since 1978, polar orbiting satellites have produced a continuous record of Arctic and Antarctic sea ice behavior, allowing scientists to study trends over time. Some types of questions that the sea ice index can answer are which months show the biggest declines in sea ice concentration and extent over time, or what years show the greatest anomalies in Arctic sea ice extent, either positive, where there's more ice than the long term average, or negative, where there's less ice. Um, the NSIDC filtered their data by removing certain ice calculations that were deemed unrealistic and likely errors. The box that would normally hold that data is just going to be empty on the data set. And the data set shows across all months of the year since 1978 a clear downward trend in both average monthly sea ice extent and the sea ice minimum and maximum extent, which demonstrates that the polar ice caps are indeed melting. So this is my first graph, and it shows the weighted average monthly ice extent covering the years 1979 to 2024. And ice extent basically measures where ice concentration is 15% or greater. And we have years on the x-axis, and then ice extent in millions of kilometers squared on the y-axis. There's two lines, a blue one representing the northern hemisphere and a red one representing the southern hemisphere. Both of these lines have a negative slope, which demonstrates a downward trend in ice extent near both poles. And you could see the northern hemisphere is a more gradual decline, but both of them have reached around the same area today. So this is my second graph, and it shows the decline in minimum and maximum sea ice extent in each hemisphere from 1978 to 2024. And years are on the x-axis, and on the y-axis, we have the 5-day ice extent average, which basically measures the 5-day period each month with the highest and lowest ice extent. The orange and light blue lines represent the southern hemisphere, while the darker blue and red lines are for the northern hemisphere. And although the declines may seem small, they're observable for both minimum and maximum extent in each hemisphere, which is demonstrated by the trend lines. This shows that the ice sheets are melting at rates beyond how much they can grow, meaning researchers can project these trends into the future and predict how quickly the polar ice caps are melting. There are some data limitations with the sea ice index, such as the NSIDC receives their data from a bunch of different satellites designed and created over many decades, meaning that the tech in each of them is quite different. So the newer satellites may give more accurate information than older ones. So that old data might need to be recalibrated in some way, or it might just not be very useful. Passive microwave sensors also struggle to distinguish between thin ice and open water, leading to underestimations of ice extent in some areas. One of the main measurements, ice extent, also doesn't directly measure ice thickness or volume, which are critical for understanding ice health. Here are my references, and thank you for watching.